So hello everyone, in this particular video, let's discuss about Tower of Hanoi. We'll be discussing both the logic and the code in the same video. So let's get started. So firstly, Tower of Hanoi, you absolutely have three different things. So I have done coding on my own over here, and it's one of the best things I've like ever tried experiencing or getting the output for the Tower of Hanoi, because so far I don't even understand what is Tower of Hanoi and etc. So it's basically you just shift the slots of the things. For example, if I have like three things over here, I just try to shift the things out like this. The disk here, the disk is here. I'm sorry. Maybe I'll just give you for one example for n equals to 3 disks, okay? So I need a couple of copies of this. Maybe I can do that, right? Yeah, I can do this. And I need one more. I need one more. I need one more. A 4, a 5, a 6. Actually, I need 8 because it's 3 disks. Actually 7. Sorry. How many? 1, 2, 3, 4, 5, 6, 7. Yeah, that's perfect. And the very first thing I would like to tell you guys is basic thing. Please use the formula of 2 power n minus 1 iterations only. Because whatever you take, for example, there are 23 disks for me, okay? There are 3 disks like this. I need to shift all these disks. How many iterations are required? Just substitute n equals to 3 here. That gives me 2 power 3 minus 1, which is 7 iterations. That's why I was asking for 7 different couple of copies of the same thing to explain you guys. So firstly, how will you do this? Actually, there's some logic over here. That is, you have to always follow this. You will perfectly achieve anything in your life. Three rules of, or three golden rules for a Tower of Hanoi. And finally, A to D, where S is this, auxiliary is this, destination is this. Fine. So now I'll start. So in my first iteration, I had to shift because this is my first iteration, so I can't just leave this as it is. I'm sorry. So my first iteration, I'll take my small block that is source to destination. I'll put. That's my first golden rule. That's what my first golden rule was telling, right? I'll put it into my source to destination. And my second golden rule is source to auxiliary. Source to auxiliary. Go to next golden rule is auxiliary to destination. Follow this, bro. Again, once over, you will just repeat it. Move to auxiliary to destination. But one of the important rules you have to know over here is this. Yeah, that's me. Okay. So one of the golden rules are this. One disk can be moved at a time. A disk can be moved only if it's on the top of the rod. And no disk can be placed on the smaller disk. That is, you have to have a larger disk, then followed by a smaller disk. Always. You can't place the smaller disk on larger disk, and only the top of the disk can be moved. And what was one more rule? That is, only one disk can be moved at the iteration. So that's what I'm doing. So now I initially moved till this, but if I see auxiliary to destination, this one is bigger than this, right? This one is bigger than this. So what I have to do, I can do the inverse of that. That is, I can move from destination to auxiliary. Yeah, you heard it right. Destination to auxiliary. If it's not possible in the vice versa. And now we're gonna go for, again, repeat it. Once auxiliary to destination is over, that is destination to auxiliary, I'll be going to source to destination. That is again source to destination. That is, this exists the same. And that's my largest of largest blocks will be to the destination. And once source to destination, I'll be going from source to auxiliary, right? So from source to auxiliary, there's nothing. Therefore, since from source is empty, what should I do? The source is empty, I'll do the vice versa. Because if I can't do, I'll do the vice versa. So source to auxiliary is empty. That is source to destination, source to auxiliary, and auxiliary to destination. We are over here now. So source to auxiliary is empty. As the stack is empty, I can't push anything to other one. So I'll do the vice versa. That is, push it from the source to, auxiliary to source. And this is how it exists. Now, once that is done, go from auxiliary to destination. Auxiliary to destination, yeah, you can do that. Since it's less, I'll do it this way. And then after auxiliary to destination, I'll again go back to source to destination. That is source to destination. That will go over here. pretty golden rule, right? So this is how you do your Tower of Hanai, any kind of logic, and this is the perfect logic I wanted to tell you guys. And let me give you like a pseudo code to actually apply what we were doing till now, like till now what were we really doing. So in Tower of Hanai, we just found out this is for odd number of disks, and the disks can be like the disks over here, you can just name it so that this is larger disk, this is smaller disk, followed by even more smaller disk. So you can have it in this ways to represent the size of disk in terms in for the computer terms. And this is for odd number of disks. And what about even number of disks? Will it be the same? Actually, it would differ. If you want, you guys can try and see the source to destination kind of thing does not work over here. So instead, what you will do is for this particular thing, you have to swap one thing. That is, just swap the auxiliary and destination. That is, swapping the auxiliary, you swap the auxiliary and destination so that the final answer would be inside the auxiliary element. If you want, just you can go give a try and come back. Just pause the video, go try and come back by swapping this. So let me give the logic for this thing. If I mod 2, that is the number of disks. So number of disks is 2, that is mod 2 is 0, that is even. Then you have to swap the two stacks, or basically it's like swapping the letters you print only. Okay, swap the letters, the characters around you swap. That is initiate char tempus a auxiliary destination. So char, now char a auxiliary, that is auxiliary. Okay, make it as auxiliary. Only aux and destination is swapped. This is destination character. Now destination character will have auxiliary character. Okay, and I'll tell you what this exactly means. Then I mod 1. So here actually not 1. You do I mod 3. The I is the number of iterations. So each and every one, for example, this is iteration number 1, 2, 3, 4, 5, 6, and 7. There are important points which I made mistakes, and I don't want you guys to miss out this too. I'll explain what is. Why I have to, first one is we should not start with the loop with the 0. That is, oh, I just lost my code. Okay. Over here. So first important thing is don't start the loop from 0. Just start it from 1, as you can see over here. That is the thing you can see here. Start from 1 to the 2 power n minus 1 I was telling. Okay, less than or equals to 2 power n minus 1. So that is because the iterations are only mattering for the swapping. If you see for this iteration 1, you will do it from S to D. Iteration 2, S to A. And this is A to D. S to D, and then you do S to D. Here you do S to A to D. Again repeat S to D. So every mods over here, it keep on repeating. So modulus is the best choice. So therefore, I mod 3 equals to 1. If is that case, I will swap S to D. If it's greater or equal, I'll check it further cases. We'll see. If is this equals to 2, swap S to A. If I mod 3 equals to 0, then swap it from A to D. Okay, guys? And this is odd. If it's even, only do this. This is if. If it's even, do this. Else, do this. Okay, no need to swap anything. Continue. Okay? And I think let's move on to coding so you'll understand pretty well. So always coding, let's start with the main one. Main int n is equals to sc dot next int, and my stack is integer. I need source, auxiliary, destination. So I'll push my all disk initially to the stack. For n is equals to 3, it'll go from, first I have to push my larger stack, because pop, like as we know, stack is first in first out, right? So first I have to push from the larger minimum. This is the first important point I would like you guys to note it down, that the I value you're pushing should be from the greater to the smallest, else you will lead to errors while changing it. And next one is your part I would like to talk about is pushing. After pushing your stacks, you're naming my auxiliary and auxiliary, I mean source, auxiliary, destination to ABC, because they have labeled me like this. My summation should be having in this format. So however, source to destination or the source to auxiliary, instead of that I'm making it as ABC. That is, the source is my A, The source is my A, auxiliary is my B, and destination is my C. Okay, in that case, I'm doing. And then you go over here to check if it's even or odd. So if it's even, I would just where was I? Yeah. So after this, after saying the ABC here, I'm going for the even or odd. If it's even, I would make my the destination. I told you, right? I'm changing just the variables. That is the character variables. I'm not changing anything else. I'm just changing the character variables. After changing the character variables from int I equals to 1, I told you the next important point. So guys, there's two important things to be noted. The very first thing is push it properly. Push it. While push it from largest to smallest. Push it from largest to smallest. And second important is start from I is equals to 1 to 2 power n minus 1. Okay, this is very important. Don't start from 0 to 2 power n minus 1 minus 1. Maybe don't even try to think about this. Don't think iteration is just a number, because you're applying the iteration value only for finding this mod. So be careful for that also. Two important things: push from largest to smallest, and the vice versa. Next is after swapping. Now one means you will move it from the source to destination. So guys, the source to destination is nothing but just the variables. I told you, right? That's why I'm just swapping the variables while it's even, I'm just swapping the variables without minding anything else. So this is just variables, but actually internal thing, whatever is happening is from source to destination is this only. So I am taking it from the source to destination, source to auxiliary, auxiliary to destination. The same thing, this is our stacks: source to destination, source to auxiliary, auxiliary to destination. Fine. And now moving further, this is my logic, guys. And I was telling that why are these many cases? Why can't you just push whether check the previous one is empty or not? Because we have seen that previously. Since here, if you see, in which case we had a problem. Yeah. So here you had to push it from the source to destination. I don't remember exactly. It was empty. From source to destination, I have to push something, but I had to do it from destination to something. Okay, I hope you guys remember, right? There was one kind of controversy. I think it's from, yeah, source to auxiliary. So in previous case, from source to auxiliary you did. Then here is from source to destination first. Second position, source to auxiliary. Fine. And third is from A to D. Yeah. What have I done? Was I doing right? Yeah. Oh, oh, yeah. So from A to D, I have to do. I think I'm just messing up with myself. So this is from. So it looks clumsy. So I'm getting confused over here. So let's be peaceful in life, guys. Wait a second. I'll just come back. I'll just change the color and boost my mind. First one, source to destination. Yes. Second one is from the source to auxiliary. Done. Third one is auxiliary to destination. So from auxiliary to destination, what I have done? Did I do a mistake? Actually, it should be from auxiliary to destination. From auxiliary, I have to put it to destination. Why haven't I? Because, yeah. So why did I do this? Because I have unwantedly included the previous in the iteration step. If you see this, you'll understand. So if you see here, I had to push it from source to auxiliary. So from source to auxiliary, if I try to push, the source one is greater than the auxiliary. So I can't push. So I had to do the vice versa. That is from the, I had to push it from the auxiliary to the source back. So guys, I was able to do that properly, but I don't know why I'm a little messed up with this. Maybe I have to draw a new one and explain you guys. I hope you understood, right? At that particular point, you got it right. Just follow the same. Again, don't. Okay. So first, if it's empty, if source is empty, I can't do anything. From source to destination, I'll explain you here in this case. It'll be better. So from source to destination, I have to put it. But the source is empty, but I need something to put into this. Then what to do? The source is empty, guys. So I have to do the inverse process. That is, I have something in my destination. I'll try putting it into the source. So you have to follow only from the source to destination. You have to start from source is empty, because sometimes even destination can be empty. That's fine. Okay. So, and the second step you have to go with, this is the first one, you have to always check for the source is empty. For the second one, you should do with the, what if destination is empty? If destination is empty, I will take it from the source and put it into destination. I'll take it from the source and put it into destination. And the third one, if my destination is greater than my source, that is destination is greater than my source, so that I'll put it from source to destination, right? So small and big, yes, that is possible. So I'll put it like from the source, I'll put it into destination. What if my source is larger than my destination? That is like source is larger than destination. I can't put it into this. So therefore, I have to do the vice versa thing. So now I hope you can understand, right? Why you're doing this vice versa thing. So yeah. So vice versa is, that is from destination I'm putting into my source. Okay, and these are the golden rules about the Tower of Hanoi, kind of. And sorry that I messed up in between because of the clumsy diagram and the unwanted kind of things which I did over here. So yeah, that confused me a lot in the whiteboard thing because I have marked it everywhere and some random rules I have wrote. Yeah, and that's the end of the Tower of Hanoi. I hope you understood. Bye bye. See you next video.